Good evening, guys. Welcome to the Science Paper 2 revision. So, just as I told you that we have started the revisions for Science Paper 2 in our WhatsApp group. Okay, so I post the questions in the group, then I give you time to go through. Then, after I go through the answers, then I also go through the same questions and show you how to answer them. So I decided to pick some questions from 2018 question examination question paper because these questions were found there. I wanted us to start at least from the start, okay, of the syllabus for science paper 2, which is chemistry. So this question was from section B from 2018 science paper. So it was like answer all questions in this section. So from section B, you need to answer all the questions. So they said write your answers in the spaces provided on the question paper. So they mean you write your answers in these spaces here. So B1 from section B, B1. A. Describe the type of movement of particles in Roman numeral 1, solids. Roman numeral 2, liquids. So they are saying what type of movements are there in solids and the liquids. So we know solids as one of states of matter. We have 3 states of matter. We have solid, liquid, and what? And the gas. Now, what makes these 3 states of matter different is the way particles behave in each of these states of matter. Because according to the kinetic theory of matter, states that matter is made up of tiny particles which are in continuous motion. So in solid, these particles also undergo motion, movement. In liquid, these particles also undergo motion. In gases, these particles also undergo motion, but the type of motion they undergo differ. Like when they say describe the type of movement of particles in solids, the kind of movement in particles is that particles vibrate within fixed positions. So here you can say particles vibrate within fixed positions. Okay, that's how you are supposed to answer. Then we move to liquids. So particles in liquids are able to move from one point to another while restricted to each other. So you can say particles can move from one point to another. Okay, you can even say like that, it's fine. Then we come to B, they are saying chemistry has been found to improve the livelihood of mankind. They mean chemistry itself has been found to improve, to make the life of human beings to be good. Then they're saying state 2 benefits of chemistry to mankind. So how do we benefit from chemistry? So when someone acquires the knowledge which chemistry gives, then they now become aware of how different combination of elements can lead to the formation of new substances. And some of the new substances which can be formed are of help to us. Like number 1, we can say The understanding of chemistry has led us to understand how to manufacture fertilizer, which is used in agriculture. So we can say it helps with the knowledge to manufacture. To manufacture is the same as to make. Manufacture fertilizer used in what? In agriculture. Okay? Then the second importance of chemistry or benefit is that you can say it provides us with knowledge which is used in the production of fuel. So fuel which we use is not found naturally in nature as fuel. Fuel is found in nature as crude oil. But through the understanding of properties of mixtures, we can understand that we understand that the components of mixtures retain their physical properties, such as boiling, melting, and also solubility. Because of that, if we have a mixture like crude oil, we can separate those components by evaporation to come up with different types of fuel. Not only that, but also chemistry helps us in the production of metals. The knowledge that we have in chemistry, we can now understand how to extract metals. So there are many ways in which chemistry help us make our life to improve as human beings. So let's go to the next question. So the next question was picked from 2009 paper. So the question was like, the diagram below, study the diagram below and answer questions that follow. So you study this diagram. Okay? So in your study, you have you have B, capital A, capital B, capital C. Let me circle them. You have capital A, capital B, capital C. Okay? Then we have also small letter. This one should be F, D, and E. So let's focus our now attention on A. When we look at A, it is a state or it is a substance. Now, this substance, in which state is it? It looks like it is in a solid state. Why? Because the particles are closely packed. However, these particles, regardless of them being closely packed, they are not regularly arranged. Because they are not regularly arranged, what can we say? This is not a solid. It is a liquid. So we can conclude that this one is liquid. A. That is our study we have identified. Then we come to B. When we look at B here, guys, we will notice that B, the particles are closely packed together and they are arranged in order or regularly. Because they are arranged in order or regularly, then this means that B is actually solid. Then when we come to C, the particles are not regularly arranged. In C, particles are not even closely packed. They are quite far apart from each other. So they are spatially packed and they are far from each other. So this is the gas. Then, after we do that, we are told that NB, we have D, E, F are processes. So F is a process from C to A, meaning a process from what? From gas to liquid. So these substances or these different states of matter can change depending on temperature and pressure. Like a gas can change into liquid if a gas is cooled. When you cool, you remove heat from the gas. And when you remove heat from the gas, what happens to the movement? They slow down. What happens to the energy is removed. And when they slow, what happens to the forces of attraction? The forces of attraction increase. And particles stop moving very fast and far from each other. And this gas becomes liquid. And that process from liquid to gas, we call it what? We call it condensation. Okay, then we also have this process D here, from liquid to solid. So a liquid can also become solid. So this process in which a liquid can become a solid is called what? It is called solidification, or we can also call it freezing, guys. This is how you study as a pupil when you are trying to answer a question. Then you look at from also B to gas. If something is solid and then it changes to gas, what process is that? Solid, directly from solid to gas without going through the liquid. This process E, we call it sublimation. So having analyzed our diagram like that, let's look at what the questions were. So A, they're saying name the processes D, E, and F. So we have already named them. Like D here, we said it is either solidification or what? Or freezing. Then if we come to E, E here is sublimation. From solid directly into gas. That is sublimation. Okay? Then F, from gas to liquid, we said condensation. We can also say precipitation, especially in geography, they like calling that process precipitation, which leads to the formation of rains. Precipitation, not like that. The spelling is not correct. Precipitation. Then they're saying, describe what you would do to convert substance A to B. So substance A, which is liquid, becomes solid, what can we do to substance A, which is liquid, for it to become solid? We remove heat from it by putting it in the fridge. So describe what you would do to convert substance A to B, meaning liquid to solid. What can you do to a liquid in order for it to change to a solid? You can do what? You can cool it. Cool it, which involves removing heat from it. So remove heat from it, then it becomes cool. Then see, state one of the basic units of matter. State one of the basic units of matter. So according to the kinetic theory of matter, it says that matter is made up of tiny particles which are in continuous motion, and these particles are known to be basic units of matter. So basic units of matter, guys, are, you need to know them, are what? One, atoms. Hii keyword in basic units of matter. So the atoms, we have again ions. Don't write ions like this. This is wrong. IONS. Then also molecules. These are the three basic units of matter, but they needed one. So you could have stated any one of these. So we can say atoms. No problem. You can say ions. No problem. Or you can say molecules. But don't put all of them here, because I know the answers. Let me put all of them here. No. They just said state one. So whichever from these you put here becomes the correct answer. Okay? Okay. So let's move to the next question. The next question came from 2010 paper. It said, use your knowledge of the kinetic theory of matter to suggest a reason for each of the following. A, wet clothes dry more quickly on warm days than cold days. So you tell us, using the knowledge of kinetic theory of matter, which you have acquired from grade 10, to now do what? To suggest the reason as to why wet clothes dry more quickly on warm days than cold days. Like when you wash clothes, when it is warm days, especially are days in October or summer season, clothes would dry faster. What could be the reason? So the reason is that during a warm day, what causes a warm day? A day to be warm. There's more heat, right? So warm day means more heat. Now, what does heat has to do with making the clothes drying quicker? Heat gives the particles, water particles in the clothes, the energy for them to evaporate faster. Okay? So what are we going to say? We are going to say during warm days, there's more heat. During warm days, comma, there is more heat, which gives energy to water particles in clothes or clothes for them to evaporate faster. Just like that. I've even done more explanation here. You can just say during warm days, there's more evaporation. So you can even say during warm days, there is more evaporation. Okay, just putting that answer here, it can be correct. Then indeed, solid ice loses its shape when it melts. So solid ice, we have ice, which is saying solid ice will lose its shape when it melts. Why does solid shape, or why does solid ice lose the shape when it melts? It changes shape. Why solid ice loses its shape when it melts? Because forces of attraction holding particles together in solid become weak. So say because forces of attraction, this is attraction holding particles together become weak. So leaving it like that is okay, because for a solid to become to melt, it means that the forces that are holding the particles to be in a solid are no longer there. Hence, the forces begin becoming weak, and as they become weak, the particles begin moving away from each other. As they begin moving away from each other freely, then the state changes from solid to liquid. Then they're saying, see, salt dissolves faster in hot water than what? In cold water. So, again, when it comes to dissolving, dissolving involves movement. So those particles move, and also the forces holding particles are strong, are weak, they become weak, and particles move faster again. So salt can dissolve faster in hot water than in cold water. Why? Because in hot water, particles are able to move faster than in cold water. So we can say because in hot water, particles, we can just say particles have more energy to move, and this helps them to dissolve faster. So that is that. Let's see if we have another question. Yes. Then they're saying when sugar is dissolved in a glass of water without stirring, or of the water soon tastes sweet. So they're saying we suggest a reason why when you put sugar in water, you put sugar in what? In water. Even without stirring the mixture, you find that the water becomes sweet. So now what could be the reason? This is because particles diffuse. Sugar particles dissolve and diffuse to all parts of water. Okay, you say because sugar particles dissolve in water and diffuse. You know, diffusion, movement from a region of a low concentration to a region of from a region of high concentration to a region of low concentration. So they will diffuse through the water. So because sugar particles dissolve in water and diffuse through the water. Then, okay, let's move to another page. This one was in 2012. They are saying matter is classified as solid, liquid, or gas. State two physical properties of each of the following. So this matter, as we know it already, they are saying they're classifying it into what? Solid, liquid, or what? Or gas. Now we state two properties or physical properties of each of the following solid. So what two properties do solids have? One, we can say they have fixed shape. We can also say, yes, you can also say too, they have fixed volume. Okay, so other than that, you can also say they cannot be compressed. Okay, they cannot be compressed. Okay, then in liquids, we can say they have fixed volume. Two, you can say they do not have fixed shape. You can also say they cannot be compressed. Then in gases, you can say they do not have fixed volume. You can also say they do not have fixed shape. You can also say that they are compressible. These can be compressed. they are compressible, meaning that we can compress them. An example for a process involving compressing gases is when we pump air in a tire for a car or a bicycle or a balloon. Okay, so let's see another question. So this question came from 2016. They're saying all matter is made up of small particles, which are referred to as basic units of matter. The small particles of matter are always in random motion. So what is stated here is what the kinetic theory of matter states. So they are saying A, state any two basic units of matter. Those we talked about, N, they wanted N. So you can say 1, atoms. Then 2, you can either say ions or molecules. Then B, suggest two pieces of evidence which show that matter is made up of tiny, randomly moving particles. Like they're saying, this suggestion of matter here, which we have read, that all matter is made up of small particles which are referred to as the basic units of matter. That the small particles of matter are always in random motion. This is just a theory from the kinetic theory of matter. Now, is there evidence which supports this theory? For you to come up with this theory, do you have any supporting evidence? So they're saying if you have, suggest two pieces of evidence which show that matter is made up of tiny, randomly moving particles. So the two pieces of evidence in support of this are: number one, diffusion. Diffusion shows that matter has particles which are very small and are moving. Why? Because when you spray perfume in one place, for example, if someone has sprayed perfume, you are able to sense the scent of the perfume. How? Because the scent moved from that body, from the clothes of that person to the nose. So there was that movement. Now, because the perfume you could not see it, it means it is in particles and it is smaller. Another one is also Brownian motion. So diffusion is in support for what? For movement. Movement. Then another evidence is Brownian motion. In Brownian motion, it's an experiment that was conducted by a scientist by the name of Robert Brownian, who observed that in smoke, which was put under a microscope, and then light was shined through the smoke, he observed that in there, smaller bright particles were moving in a zigzag way, like that. Okay? So they were moving in zigzag. So that kind of movement in zigzag is the one we call random. So Brownian motion supports that this movement you see in diffusion is actually random. It's not directed or it's not in order. Random means not in order. Okay? So these are the two pieces of evidence. Then we move to C. They're saying the diagram below represents one of the physical states of matter. Okay, one of the physical state of matter, which in this case we are still talking of solid, liquid, and what? Gas. So it represents one of these three here, this one here. Now they are saying, name this physical state of matter and explain why it has a fixed volume. So what is this diagram representing? Which physical state of matter is this diagram representing? First of all, let's look at how particles are packed. When you look at the way particles are packed, they are very closely packed. So it looks like it is a solid. Now, because particles are not regularly arranged or orderly arranged, it means that it's not solid, because in solid they are in orderly arrangement. So this one now becomes not solid but liquid. So if they say name the physical state of matter, it is name here will say liquid, because particles are not in order. Now explanation, and explain why it has a fixed volume. So liquid have fixed volume. Why? Because you cannot compress them. So you say because it cannot be compressed. Then we move to the other question. Okay, no, there's no other question. So this is where we end, guys. Thank you so much. I hope this revision has helped you. So you go through the videos, understand, and also remain revising. For now, bye.